Well, hello everybody. As you can see, I'm in the bonus quiz here for 6.4. This is the moment in the chapter when we no longer deal with simplifying expressions and we jump to solving equations, rational equations. And here is the rational equation. I've written it slightly larger here in red. And I'm going to use my technique of wouldn't it be nice, because it saves a lot of time and reduces complexity. But before I do that, I thought I'd show you a little game I sometimes play when I have a simple rational equation like this to solve. I just say to myself, I wonder what the answer could be without actually solving for t. In other words, I say, suppose t was equal to 1. 1's a nice friendly number. Let me go ahead and substitute 1 in for here and see if the left-hand side equals 1/3. And so that's what I've done. I've done the substitutions here. 2 times t, or 2 times 1, is simply 2. And of course, this was just a t, and I let it equal to 1. And I want to know, does this equal 1/3? Well, 1/2 plus 1 is 3/2, and 3/2 is close to 1/3, but it's not equal to 1/3. So then I said, okay, well, how about I try t is equal to 2 to see if I get closer to the answer, to see if this balance beam is a little closer to being even. When you let t equal 2 down here, you have 2 times 2, or 1/4, plus 1/2, t is equal to 2. And so you have to do this addition, and 1/4 plus 2/4 is 3/4. Now 3/4 is not equal to 1/3, but it's closer than 3/2 was. So we're moving in the right direction, and I said, let's just do one more. Let's let t equal 3 here. And so you get 1/6 plus 1/3, and we want to know if that is equal to 1/3. When you do this arithmetic, you get 1/2, not quite equal to 1/3, but a lot closer than either of these was. So we're moving in the right direction. The answer is going to be t is equal to 4 or 5 or someplace in between. So I haven't even done anything algebraically yet, but I have a feel for where the answer should be. Now here is my workup of the problem in terms of wouldn't it be nice. The technique is to create elongated fraction bars so that I can write in the factors that I'm going to need, and I parenthesize everything and I factor everything. There really wasn't anything to factor here except for 2t, which I wrote like this in classic factored form. Now, we have an equation to solve, and we are going to run our wouldn't it be nice technique. We can start anywhere, and the idea is we're going to be clearing fractions here. We're going to, by multiplying both sides, we can clear fractions. And wouldn't it be nice then, for instance, if I had a t here? Because if I had a t here, then these guys would cancel. I would no longer have a fraction here. I'd simply have 1. And so, yes, that would be nice. And so I'm going to multiply everything by t, both sides of the equation. So all the terms that you see are going to get multiplied by t, including this first one here. And then I look to cancel anything. Of course, I've already canceled these t's. These t's are going to cancel as well. And there's nothing over here to cancel. Wouldn't it be nice, though, if there was a 3 up here? Because if there was, then these 3's would cancel, and I'd no longer have a fraction over here. And so, since that's nice, we're going to make it so. We're going to multiply everything by 3. Nothing cancels here, and nothing will cancel here. Now, this is no longer a fraction, this is no longer a fraction, but this is still a fraction. And I can get rid of that 2 down there if I had a factor of 2 up here. So wouldn't that be nice? It would be, because they would cancel. But I need to multiply everything by 2. And nothing else is going to cancel because there aren't any denominators here anymore, just 1's. So now we're at the cleanup stage. We simply no longer have fractions. We can ignore the denominators, and we simply look at the tops here. And so what I have here is 3 times 1, or 3, plus, over here I have simply 6 equal to, and over here I have 2t. And now we're back in section 1.3. This is a simple equation to solve. Add that left-hand side, and you get 9 is equal to 2t. Divide both sides by 2, and you get t is equal to 9/2. And notice that 9/2 is 4.5, and I said that the answer was going in the direction towards 4, towards 5, and this makes sense with our initial substitutions to get a feel for the problem. So that's the answer, 4.5. They want us to type an integer or a simplified fraction. I said it was 9/2 or 4.5. I wouldn't want to put that decimal in there. They want an integer or simplified fraction. So 9/2 was the simplified fraction. So we have 9 over 2. And we get on to the second part. And I've rewritten this in my wouldn't it be nice format. Let me square it away a little bit here. So notice now I did have to do some factoring here. I parenthesized everything, so the x minus 8 is now showing in parentheses, and even the single numbers I parenthesized. I did crack this trinomial here, and so I forgot to put this in. And everything has been parenthesized, and the fraction bars have all been elongated. So we're going to play the game here, wouldn't it be nice? And this time I'll start at the beginning. I started in the middle in that other one to show you it really doesn't matter, but here I'll start at the first term. And it would be nice if I had that in the top because then these would cancel. And so I'm going to go ahead and multiply everything by that. Nothing cancels here, but this is sweet because the x minus 8 linear factors will cancel. And so we no longer have a fraction in the first term. The second term, it certainly would be nice if we had an x plus 4 here, because then these guys would cancel. And that means everything has to get that multiplication by x plus 4, including both terms on this side. That would be the part where you'd fall down if you didn't include that x plus 4 multiplying everything. Notice that these cancel here. But here I have simply 8 times x plus 4. I'm going to go ahead and do this distribution. 8 times x plus 4 is going to give us 8x plus 32. And over here, I'm going to go ahead and do this distribution. And I'm going to have 5x minus 40 plus 5x minus 40. And over here, the right-hand side is just simply 12x. And so we've been plunged back into section 1.3. Over here, I'm going to combine like terms. 8x plus 5x is 13x. And I have a plus 32 minus 40, which is a minus 8. And that is equal to 12x. And I'm going to make two moves at the same time here. I think we're at that stage in our 122 careers that we can do that. I'm going to subtract 12x from both sides, and I'm going to add 8 to both sides. 13x minus 12x is going to simply be x. When I add 8 to both sides, I end up with this. And so that would be the answer, except is that an allowable answer? And this is where you really have to train yourself to say the restrictions, what can't x be? Or at the end of the problem to remember to come up and check. Now when x is 8, this first fraction here will have 8 over 0. And so our answer is not an answer. And so there are no solutions. The math said x equal to 8 was the correct number, but the fractions indicate that x can never be 8. And so we're left here with this real bald fact that there aren't any solutions to this. And so there is that choice here. There you go. Those two problems. Let's see if we get green arrows. And we do. Okay, so that's the bonus quiz for 6.4 with some unique slants to it. I hope that helped.